Good
Good evening,
evening,
sir. Good evening, madam.
respected Director Professor Kannabaran, Chief Guest, Dr. Srija, Fellow Coordinator, resource persons, colleagues and students. Welcome to the inaugural session of the AICTE ATAL FDP on data science and visualization using Python. So let us begin with a prayer. So over to Dr. Srija.
वन्दे मातरम् वन्दे मातरम् सुजला सुफला मलयज शीतला सस्यश्यामला मातरम् वन्दे मातरम् ज्योत्स्ना पुलकितयामिनी पुल्लकुसुमित द्रुमदल शोभिनी सुहासिनी सुमधुर भाषिणी सुखदां वरदां मातरम् वन्दे मातरम् वन्दे मातरम् या कुन्देन्दु तुषारहार धवला या शुभ्रवस्त्रावृता या वीणा वरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युत शङ्कर प्रभृतिभिः देवैः सदा पूजिता सा मां पातु सरस्वती भगवती विशेषजाड्यापः
Thank you, Dr. Srija. So let us begin this session. In the current day of IT era, we know that data is generated humongously, that is in petabytes for every day or every hour it is generated throughout the world. And we know that data in its raw form is not a random one. There is a meaning behind the data because the data is generated by human beings, machines, by the nature, by sensors which are sensing various atmospheric conditions, and it is not a random sequence of bits and bytes. So data contains information, data contains knowledge, and the correct way of using the data is the core of the intelligence. So data science in recent years has emerged as its own field where computer science, machine learning, statistics, databases, so on are the ingredients. It has vast potential in industrial or business community as well as in the academic world. Nowadays, we can see that many universities, institutes are having data science as a branch of study. So it shows the immensity of the field. Hence, it is very important for faculty members, students, especially research students, to be well equipped with state-of-the-art tools, techniques of the data science. So this is a very significant program, especially for faculty members who are going to teach these subjects in various institutes. We are thankful and appreciate the efforts of AICTE in creating opportunities where these type of FDPs are possible, hoping that this FDP do add to your career as well as to your knowledge. So now I take this opportunity to request Professor Kannabiran, Director of IIIT Sri City, to grace the occasion with his inaugural address.
Okay. Thank you. Good evening to all of you. Professor Vishwanath, the coordinator of the program, Dr. Srija, the co-coordinator of the program, and my dear participants. I join Professor Vishwanath in joining you, welcoming you to this 2-week FDP on data science and Python. And so this is the second FDP, ATAL FDP for Professor Vishwanath. And the first FDP went on very well. And a lot of faculty members were benefited in the first FDP. And of course, Srija is one of our very young, committed faculty members. She has also joined Professor Vishwanath to offer this program. I'm sure that this program will be conducted properly with appropriate resource persons, and whatever resources have to be shared, it will be shared properly to you. And I'm sure that the 2-week program, the first 1 week online and the second week of the program in offline mode, will really be useful to you towards your preparation for teaching, or if you're doing some research, obviously it will help you to learn a few techniques and insights. And as Professor Vishwanath was saying, that this field has emerged over a period of time in the last 10 years or so, and a lot of data is being generated today through ERP systems, supply chain systems, e-commerce, across industries. And these data obviously has been a big resource. It has become the blood of any business today. And any courses of study or research in this area has a lot of meaningful applications. And it also has created a lot of career opportunities to young graduates. And we are one of the institutes to launch a BTech specialization in data science. And there's a good number of students taking up this specialization. And so obviously Dr. Srija is leading that specialization, and she will also share with you some of the details of how we evolved and the curriculum and how it is being run in our institute. And second part of the program, when you are coming to IIIT Sri City, and you will have a good time. We will make all the necessary arrangements. If some of you need some accommodation or something, we will be able to help you also. And we are also looking at an industry visit to Sri City. And some of you must have Googled by this time, where is Sri City and what is there in Sri City. Sri City is a place where it's a newly created industrial city. There was no place called Sri City about 15 years ago. And today it's a home for about 200 companies represented from about 30 countries. And you name any top companies, manufacturing company, which has got a manufacturing facility here in Sri City. And today only I had returned to the MD of Sri City for a visit. And hopefully you will go to Sri City for a presentation, followed by a couple of industry visits. So that will be an integral part. It may not be directly data science, Python and all that, but then you can really see how large businesses, manufacturing companies work, and what kind of opportunities this field data science will have in those companies. And I just went through the program, and it has been meaningfully, purposefully designed. And one request to both Professor Vishwanath and Dr. Srija is that we can also include some more industry lectures, either online or offline. We have a lot of people connected with you, Dr. Srija, from various companies. You can arrange maybe 1 hour session. It's not about these industry people taking sessions. It's about our participants getting introduced to those industry people, and they will be able to connect further and make the contacts. You can arrange as many as 5-6 short, experience sharing sessions on, not necessarily lectures. So they get connected with those of this and industry people that you can probably look at it. And to the participant, this is an opportunity to get connected. In today's world, it's all about networking, how you connected with people and what kind of people you are connected with. And this possibly has two opportunities. One is that you get connected with the faculty of IIIT TCT. Apart from Dr. Vishwanath and Dr. Sija, there are other people with whom we can get connected with. It's also an opportunity for you as 20, 30 participants who are coming together for you to get connected with each other. So this has got a multiplier effect over a period of time. So I wish that I'm not able to know who are all the participants and what are that you're doing now. But then hopefully we'll have an opportunity to meet when you are on campus in the second week of the program. And I wish you all the best. And I only once again wish that the program is useful and all of you attend all the sessions. Very important. I was in one of the review meetings recently about the ATAL programs, and there were a lot of comments about participation of the so-called participants and how many sessions they attended, how what kind of attendance was there by the participant. It was critically being commented by someone else. But then I only wish that those of you who have registered and you are there in the program, at least attend all the sessions, and not because you need to give attendance like students. It's an opportunity to learn and opportunity to get connected with people. So with that, a few words, I once again warmly welcome you all for this program, and I appreciate the efforts of Professor Vishwanath and Dr. Srija to run this program, and I look forward to see you all in Sri City. Thank you.
Sir, you have to unmute yourself, sir. Vishwanath, sir.
Yeah, sorry, I have forgotten. So now I request Dr. Srija to give vote of thanks, so that this inaugural session can end successfully, and we will go into the first session of the FDP.
Yes, good evening, everyone. It is a great honor to be a part of this wonderful event. And on behalf of IIIT Sri City and as an organizing committee, that is as a co-coordinator of ATAL FDP program, I would like to extend my heartfelt gratitude to our chief guest first, Professor G. Ganapiran, Director of IIIT Sri City. Thank you, sir. Thank you for joining. Thank you for accepting our invitation. And sincere thanks to the head of the department, Dr. P. Vishwanath, who is the coordinator of this program, for handling the event throughout. And sincere thanks to all the faculties, participants, and students who is going to make this event a grand success. Thank you, one and all. Yes, sir. Over to you, sir.
Thank you. So with this one, inaugural session will end, and we directly go to the first session. There is no need to disconnect and reconnect. There is no need, because it is the same link that is being used for all the sessions. So please stay here. So I request Professor Raju to take over, so he can start sharing his screen.
Yes, sir. Thank you, sir. I'm sharing my screen.
Yeah. So meanwhile, let me introduce Professor Raju.
Please introduce.
Professor Raju received a BE from Bangalore University, and he worked as software engineer for a brief period. And after that, he received his MTech from JNT University. He worked at various levels in JNTU, Hyderabad, Mahatma Gandhi Institute of Technology, Godavari Institute of Engineering and Technology, so on. Presently, he is working as an associate professor at National Institute of Technology, Warangal. He completed his PhD in JNT University, Kakinada, in Computer Science and Engineering with the guidance of Professor Vijay Kumar. He published more than 70 papers in various reputed journals and conferences. He is a senior member of IEEE, and he is a fellow in Institute of Engineers. Also, he is a member of ISTE. He has guided 4 PhD students successfully at NIT Warangal. He visited as conference speaker various countries like China, UK, Thailand, Taiwan, Malaysia, Hong Kong, as well as USA. So we are happy to have Professor U.S.N. Raju as a resource person with us. Now I hand over the session to Professor U.S.N. Raju.
Yeah. So thank you, sir. So is my screen visible? All the participants?
Yes, yes.
Yes,
Yeah.
yes.
Yeah. So thank you, sir. Yeah. Good evening to all of you. So today I'm going to give the introduction about data science and big data, and the different works that we have done on big data related to this data science and image processing that I'll be showing on 7th, where I have one more session on on Saturday. Okay. So I think Vishwanath sir already told what is data science and how it has evolved and what are the components of the data science. It's one or two slides I'm talking about data science. Then after that I'll be talking about how that big data can be considered as part of data science and what are the different components of that big data. Okay. So but before going to this session, I think I request all of you go through this for 2 minutes. There is a small story here. Okay, I hope all of you have completed this. So finally, what is your reply for it? You want to become Tom or Chris at the end of this? So because what I want to tell is that both of them have started a particular work on the same day, same time, but one reached to some uh, like higher goals, whereas the other person is doing the same task repeatedly with the same amount of money. So even those who are attending this workshop, so just for the sake of certificate or just for sake of attendance or just for the sake of somebody just to get some just to get the promotion and kind of thing by using this certificate, then that is of no use. So whenever you are attending this, you have to keep in mind that you are really want to learn something from this workshop, so that you also can start doing wonders how that other person has done, that Chris has done. So for all this, what you need to have is that you need to have that ambition to say that you want to reach it. But really speaking, no, when you talk about this big data, because nobody in the world knows big data by birth, that we have to understand. So in the same way, that same thing is applicable even to me. So I started just I was working in image processing during my MTech and even in PhD. Like around few years back, around 4 to 5 years back, I'm also not having any idea about big data. But at that time, something like made me to start looking into that big data. I'll tell why I started that big data technologies to my basic fundamental image processing. But after that, really, whether you believe it or not, now, as of now, I can say that I made a cluster of 115 systems with Hadoop software, and that same thing I have uploaded into YouTube. And even recently, we processed to 20 crore images, 20 crore images for their compression and decompression. That is one of the tasks. But so my dream around 4 years back was to handle only 1 crore of images to process. And what kind of process that I want to do, that is different. Okay, in image processing there are different algorithms, but at least my task is to just to attempt to process 1 crore images. But because I, I tried. It's not only because of me. I tried along with my students at NIT Warangal. Last year, we could able to make processing of 20 crore images in the technologies that I was telling. I'm about to tell about that Hadoop and Spark technologies. So main thing is that you have to involve in the work, whatever the work that you are doing and you will be doing. So you can reach to anything that you are really expecting. But just by listening or just by just for the sake of certificate, if you are writing, at the end you will get only certificate, not the knowledge. So by keeping that in mind, please use attend all the sessions as our director told. So you need to always think about like attending all the sessions. If you simply attend, surely you will be more than zero. That you have to keep in mind. You may not be getting the whole thing whatever I did for 5 years, or whatever the other resource person that they might be telling, which they might have tried it for even more than some time, 1 year, 2 years, or 3 years. But don't expect that you will be getting the entire knowledge what the resource persons are having within this 1 week, but surely you will be getting some delta. With the delta, from there you need to improve, so that you will be getting some. Those who want to get some better job, you can get, and those who want to get some research output, you will be getting all that you get. But the only thing is that you have to have that aspiration and ambition to reach your goal. And really, to start about this, as Sar has already given the definition of data science, it is the same definition. Whoever tells the definition of data science, there won't be any change. If you go through multiple sources in the internet, you may be finding different way of writing the same statement. So even some of the things, whatever I am showing, I have taken from internet, and some of the content is my own, where I'll be showing that. And so data science, as people are crazy about this word data science everywhere, people are talking about data, data, data. So what is that? Ultimately, the goal of this data science is about is all about dealing with some amount of data. But here, when I say some amount, he is telling it is about what is not simply some. It is like even more than what we expect. Okay, and by handling the data, whatever you want to do, what we want to do from the data, just to find out some patterns in that, as Ishnath sir also told in the beginning. So simply it is, as the data is created by the humans, so they won't just do some rough. They never create some data which is of no use. So whatever that they are doing, there is some meaningful information hidden in that. So the target of this data science is to find out that hidden or that pattern, to analyze that pattern and find out that hidden meaning in their in that data. And so that what is the advantage of doing that? If you get say, okay, by analyzing this, I understood that the data is like this. So it is all for mainly for business decisions. Okay, so this is about all about data science. But once if you go to the technology, there are thousand like different around 7 to 8 technologies are involved to make this as this is considered as data science. Okay. Now, so generally, as I'm talking about this data science is all about data. So what are all the like components of the in that looking into that data? So first we need to capture the data. So in the coming slides or show, I'll be showing how what are the different ways of capturing the data, and what are the otherwise what are the different sources of sources which are creating the data. Once if their data is created, then we should be in a position to capture that data, then maintain the data. Okay, so then you have to process it. By processing, you will be getting some knowledge. Then knowledge need to be analyzed. Okay, and analyze and take the appropriate decision, and finally it has to be communicated. Of course, I'm talking about just briefly about these 5 components. But once if you go into maintenance of the data, so here they are telling, no, I think data warehouse is one subject, and data staging, data processing, and there are different architectures that are used for maintaining. And even one of the data maintenance is also about big data. I'll be talking mainly about big data only. So data science, just 1 2 slides only I'm talking. Then this is the same thing which is given in the one of the internet sources. I've taken this diagram. And what are the different technologies that are used for data science? So these are the different technologies. I think in the lab, uh, for the work, this FDP itself, they have given something like data science by using Python. And in addition to Python, actually, I worked with this Hadoop and Spark. Okay, when we worked with Hadoop and Spark, Python is automatically comes based on the requirement, but this is there are all the different technologies that you can use whenever you want to do something in data science. But R, I don't have any idea much about this R, and other languages, also, other technologies also I don't have much. I'll be talking about Hadoop and Spark, and even about MapReduce, how that MapReduce technology is used to analyze the data. And about the job opportunities, I think, as you know, people are even talking about data science, and there are some colleges and universities, they already started with a specific branch name, its branch itself as data science. And even almost majority of the universities they are following, and it's all about data science, because there are a lot of job opportunities. And there is these are the statistics I have taken from some website. And even if you consider the basic salary is good, and even this is the second best job in America in 2021. So these are all the different reasons. Of course, even if you start searching about some other uh, technology, there also you will be finding some kind of similar numbers. So don't think much about it, but ultimately it is the one of the good technology that you remember. Then, okay, that is all about data science and all. Now if you really want to look into this that big data concept, so these are the things that are given as per the your lecture schedule. So first I'll be talking about data. Yeah, please all of you read this definition. Okay, so now we are talking about, whenever you talk about computer data, that is about bits and bytes. But it does not mean that before bits and bytes there was no way of maintaining the data. So whatever that we have written in our text in our notebook, that is also considered as data. But as we are about to talk about this computer technology, so we'll be talking everything in terms of bits and bytes. As bits and bytes is all related to electronic device. This is just a definition that we teach for the first year students, BTech first year students. And when same way how the data is represented inside the computer, so we know we started with 1 bit, then we know one nibble, that is 4 bits, then 8 bits, then 1000 bit. Okay, so 1000 bytes, that is 1 kilobyte, then 1 megabyte, and there is so on like that. So now I think even with like around few days back also I heard about the only up to this yottabyte. But when I started searching the internet just a few days back, I found this new technology, that is Brontobyte, and I don't know even how to pronounce this Geobyte. Even I saw like one more website. Even I don't know how much really they are standardized or not. Even when you go this, it is going even beyond that. So those many number of bits are to be captured, stored, maintained, analyzed, and need to be displayed. So you imagine, so only for if your computer, what is the generally our computer memory? If you say 1 terabyte, and we know how much like it is 1 terabyte, but now you see here you are somewhere just here only 1 terabyte. There are so many after that terabyte. So there should be some mechanism to capture all such kinds of data, which is very big in nature, and it has to be stored, processed, analyzed, and to be displayed. Like final results need to be displayed according to the business requirements. Okay. Then generally, if you consider what and all that is going to happen in the world for one day, and this is very old statistics I can say, but if you go to internet and find out the new statistics, even just a few days 2 days back I saw it in one newspaper. Like 1 minute also they have given how much data that is being created. And whatever the data that is created by all these electronic devices is not simply thrown away. So they're all keeping in different storage devices, and they are maintaining it and they are analyzing it. And this is also about what are all the things that can happen in 160 seconds. And so how many YouTube videos that are uploaded, how many Twitters are tweeted, and how many Instagram messages, then Google like Gmails, then Facebook updates. So not only this, you can just and actually here yeah, this is one website. Generally, if you want, just you can verify it. When you go through this website, there are. This is not the only one of the one website. This is not the only one website. If you want, you can go to some other websites where they are really showing the live numbers, how much data that is being created. for every 1 second or even less than 1 second. And so why I have started with this big data, I'll tell this small story what happened around 5 years back at NIT Warangal. So basically, I work in image processing, but actually during like in 2015 or 16, 2016, I have given some assignment to the students. I think in those who are from computer science, I think you know what is pumping lemma for for regular languages and contextual languages. And we know that the theorem is bit typical. Even today, I can say it is typical. So for that reason, I explained it in the class and asked the students to submit an assignment, but not as a written assignment. So if it is a written assignment, everybody can just write something whether they understand it or not. It doesn't matter. Simply they copy it from some textbook or from some friends' notes and they can submit. But I asked them to submit by recording. What they need to record? They need to record the explanation of the pumping lemma, which is explained by them. And if generally you also know because majority of you are the faculty, I think so. So whenever you want to explain it to somebody, obviously you need to you will be preparing a lot when compared to just writing for exam. Even some people know they may be getting 100 out of 100 in some exam, but when I asked them to explain, surely they may not be in a position to explain properly because the way that we prepare for exam is different from the way that we prepare for explaining it to somebody. We have to get more idea, more clarity on the concept, then only we can start explaining. So here, what happened now? So everybody has submitted, but because of that available software at that time, so some people have cut and paste that videos from their videos to their friend video. Then I realized that I want to find out the copying in the videos. So it is like that. For example, one student has submitted his video, and let us assume that the total duration is 5 minutes. And another student, what he has done is that, and in this, yeah, first student, this 5 minutes. So 1 minute, he just to assume that he is visible, his face and everything. After that, the that camera is focused on to pen and paper. He explained it on pen by using pen. He has explained it on the paper. So next student also he was visible in the video for 2 minutes. After that, he cut and pasted this content. When he cut and pasted it here, so obviously we can't really know whether he has done or he has copy pasted from somebody's. So when I need to handle around um 130 videos at the time, and I felt it is very difficult to don't get all those videos and store and processing. So at that time, as big data, people are talking about big data, then I started learning that. So because of that, really I can say that I guided two projects in this big image data processing only. And before that, I never knew anything about big data, but just to start using it along with image processing. So if you people also, so you need not think about somebody gives some research problem. So based on the situation, based on the circumstances, you yourself can decide like what is a kind of what is that a research that you can start. And obviously, when you say and you yourself are getting such problem into your mind, and if you want to start doing, obviously you need not compare about, you need not think about whether somebody is doing in that or not. Obviously, you also can start. There won't be any plagiarism problem related to your work with somebody's work. And these are the different big data like business applications and different software that are used for big data. And finally, I want to just give the definition of big data. Yeah, I think I think some of you have heard about this big data. And big data is part of data science that you need to keep in mind. As in the beginning itself, I told that you need to handle huge volume of data. So, yeah, is my voice audible?
Yes, sir. Yes, sir.
Yeah, yeah. Okay, before going into the actual definition, can any one of you can just tell what you know about big data, what you are thinking, as the word big suggests?
So as I know, big data is nothing but it's a huge amount of the data which
Hmm.
is over the Twitter, Facebook, or YouTube over there,
Okay.
uh, and and whatever the knowledge we have to require, we extract from that. We collect the data from the big data and we clean data, we analyze data, and we extract data
Yeah, yeah. Okay,
as
okay.
per our requirement. That is big data and data process.
Okay. So no, no,
Yes, sir.
because yeah, thank you very much. But what do you
Yeah.
mean by huge? According to you, how much is considered as huge?
Huge means as I read in some over the internet, in
Hmm.
Twitter and Facebook or like WhatsApp, everywhere in one day, I mean more than 2 or 3 million data is generating every day,
Hmm.
and as per the our requirement, I mean the like text if we require the text, then text data, then we go through this medium like Twitter or Facebook, and we
Yeah, yeah, yeah.
collect
No,
data.
yeah, sorry. Yeah, can you quantify the word huge here?
Use uh, use I mean in the bulk amount of the data is over there.
Yeah, yeah. So you are telling synonyms.
Mm, yes sir, yes sir.
Uh, no, no. When you will be saying that you are looking into huge data, like according to you, what is that huge? Can you say some number for that or?
No, it's it's I mean unstructured format raw data, so not a number.
Yeah. Okay. Okay. Then thank you. So I'll be telling it. So simple
Yes,
because generally whatever I understood with the big data, I'm telling in my own examples. Now let us
yes sir,
assume that you have 1 liter water bottle.
yes sir.
Okay. Then what is it like? What is the maximum water content that you can store in 1 liter water bottle? 1 liter.
1 liter, yes sir.
Okay. Now let
Absolutely.
us assume that one of your friend is coming to you and he asks you to store 1.5 liter with you for some days because he is going away out of station and he is
Okay.
your close friend and he
Yes sir.
came to you and asked you to store that 1.5 liter with you. Then how you will handle it? Because but you have only 1 liter bottle and he is your best friend. You won't be saying no.
Oh, in
Then
that case,
yeah. Generally, as he is your best friend, no? So you want to
yes sir.
buy 1 2 liter water bottle.
Absolutely.
Okay. And
Yes sir.
he kept that water with you, and after a few days he has taken it away. And every time he is telling that it is only for temporary. It is not permanent storage. He want to keep that water with you for few days. Okay,
Okay.
you did it. After a few days, that same friend came with 2.5 liter now. And once again, he
Yes
is the
sir.
same friend, same feeling, and won't be saying no to him. Then, okay, next time also you tried, you have money with you, and you bought a 5 liter water bottle now. And
Yes sir.
you kept the 2.5 liter once again. So, problem is solved. So, after a few days, once again, he is coming with the 5.5 liter. And every time, please you think that it is only temporary.
Temporary. Yes sir.
Then, once again, you thought of buying, but now you don't have money. Then you realized exactly. So, because he is coming every time and you have to help him, and now you don't have money, then you realized the importance of the word temporary.
Temporary. Yes sir.
Then, instead of buying every time, then you have taken one more bottle from your neighbor. This is your 1 liter water bottle. And let us
Yes
assume
sir.
that your neighbor is having some empty bottle, he is not using it for so many days. And as of now, you have 5 liters, no? He is having 2 liter water bottle, and you requested your neighbor to get the bottle. And let us assume that you have connected it by using straw.
Yes sir.
When I say you have connected, why I'm telling that you need to connect, I will tell you. Then, what is the total capacity of your storage now? Because you have connected your 5 liter water bottle with 2 liter bottle with one straw. And somebody asks, what is that total? How much you can store now?
7 liters sir.
7 liters. Okay, now
Yes sir.
you because but he is coming with only 500 liter. You managed it, and after that you have returned back that 500 of liters water to him. After that you remove this connection and you have given back this 2-liter water bottle to your neighbor.
Yes, sir.
Then after a few days, now he came with 10 and a half liters. Then what you have done is that now you have 5 liters water bottle. You asked one neighbor with 2-liter, and there is one more. Now instead of 10 and a half, I say it is 20 and a half. Then you ask one more neighbor who is having one 5-liter water bottle, and you ask another neighbor who is having 10 liters water bottle, and here you ask one more neighbor with 15-liter water bottle, and you connected all of them. Then what is the total capacity? 10 plus 15 plus 2 plus 5.
5.
25 plus 7, 32 liters.
72 liters.
And you
Yes,
can
sir.
store that much. So what you need to understand here is that whenever big data is a relative term, we can't quantify the word big. Because initially when he came with 1.5 liter, then also you thought when you have only 1 liter water bottle with you, then you realize that oh, he is coming with a lot of water, then how to deal. But in the same situation when he is coming with 1.5 liter, let us assume that you have 10-liter water bottle with you. Do you ever thought of like expressing that he is coming with lot of water? See,
No
you have
idea.
to deal with this 1.5 liter, whether we worry or not. You
Yes,
have
sir.
no, you have 10-liter water bottle with you,
Yes, sir.
and say your friend is coming with 1.5 liter, and he is
Uh-huh.
asking, he's about to ask you to store that with you.
Okay.
Do you have any feeling of like how to
No,
handle this 1.5 liter?
no worries, sir.
No worry,
No worries, sir.
because no, but previously for the same 1.5 liter, previously you were worrying. Why? Because you have limited storage.
Yes, sir.
Okay, so that means it is a relative term. Then ultimately, whatever the storage that you have, if you need to handle anything more than that, we'll be saying it is about volume part of big data. Because of course there are different properties of that big data. We'll see it. But here, at least when I'm talking about the volume part of this, so you need to think that it is a relative term. For example, if your computer is 1 terabyte capacity, then if somebody asks you to store 256 GB of movies, do you find it is difficult to store 256 GB in 1 terabyte system?
No.
No.
No, sir.
By chance, if you have same 1 terabyte system, if somebody is coming with 1.5 terabyte of some data, and if we ask you to store in that system, then we need to start worrying about it, how to handle it.
Yes, sir.
So here, with respect to big data technologies, how they handle is all about getting it on rent that you need to consider. You need to think, you need to understand.
Okay.
So even now, because ultimately the storage is temporary. Because of the word temporary, I can say that I'm getting the bottles from my neighbor and I'm connecting them. And when I said that I'm connecting, simply I can say that I'm making a cluster of computers. I think those who have studied about Hadoop, you might have come across this word Hadoop cluster. That's it. One Hadoop cluster means it is connecting computers. When I say that I connected the computers, the storage which can be considered as a shared content can be shared or be considered as the total amount of memory that is available to store. Because here, see, 5 liters it is empty, and 2 liters, 15 liters, 10 liters. Then the total storage of my cluster is sum of all these components. So big data is all about how to handle the storage problem. So what is the storage problem? When you can't store the amount of data which is about to process in the available resources. Then how to handle the storage? By getting other resources which are available in the with you as of now. That's why those who have heard about this big data, you might have heard about the word commodity hardware. Have you heard about this? So don't start buying. If you start buying, then there is no point in talking about that software Hadoop. So even I really tried in by keeping that community hardware in the mind. When I said I made a cluster of 115 systems in our college, community hardware in the sense the software, the hardware which is available in our lab on that particular day. So you should not start buying some big servers and say that you have done Hadoop. Hadoop is meant for managing or using do the processing or storage everything with no cost. When I say it is no cost, that means should not spend even a single pay for spending the hardware. You should not spend even a single paise to buy the software. We'll see how it can be. So main thing is about the community hardware. This is the storage. And other example in big data is processing. So this is because really whether you if you understand these two components, so whatever the textbook or whatever that you read in the big data, other than these two, I didn't find anything from past 5 years. Only storage and processing. How you will handle the storage mechanism when you can't store with your available resources. So get it from your neighbor, you connect them, use it, after use it, dismantle it and send them back. Exactly the same thing is applicable to computers. When I said that I'm connecting so many computers and I can say that I made a cluster of computers. Then processing. So this is also one simple example. Now let us assume that this is you and this is your head of the department, and let us assume that he has given 100 TOC answer scripts to you, theory of competition, and he asked you to complete it in 2 hours. So because of some reason, you need to complete it in 2 hours. But we know that that can't be completed in 2 hours. Then how will you handle the situation? And we know that we are not Rajnikant to correct the papers by using two hands simultaneously and all. Yeah, how will you handle this situation?
We distribute the work to among some friends who
Yeah,
can do this.
yes, very good. Who can do this? That is important. Then you tell me who can do this thing. Do you think that only the person who like let us assume that you are an assistant professor. Do you think that only an assistant professor can do it? No. So you called your friend who is an assistant professor and you requested and he accepted. Even an associate professor who is having even more experience, I'm not talking about designation, I'm talking about the experience. And this associate professor, he taught it for 10 times the same subject. And when you requested, he also said he want to help you. And assistant professor who taught it for 2 times, he also accepted to help you. And there is one professor when you called no, he also told that he can help you. Professor in the sense I can say that he taught this subject for 20 times and he has written 2 textbooks on this subject. And even you called one senior student who got 100 out of 100 in the last semester, and all of them they are ready to help. Then what is the difference among these 4 people? And who can do the things faster here? I can say professor, because he taught
Professor,
the
yes, sir.
subject for 20 times and he has written 2 textbooks on that and he is ready to help you, means he is having more processing power. And here it is a bit less and so on like this. Why I'm so specific about this example, big data, no, if you go through the internet and you textbooks, you will be finding that in big data, when the systems are connected and made as a cluster, we can have heterogeneous computers in the cluster. When I said heterogeneous, means you can have with different configurations and different processing powers, different storage, and all that. You need not think about, yeah, you need not think about. I think one of you, can you keep it in mute? I think somebody's. Okay, right. Is my screen visible?
Yes, yes,
Yes,
yes.
sir.
Yeah, please. Also, after asking some doubt or discussion, please you keep your microphone in mute. Right. Now, when I said that this is all about different people here, same thing is applicable to computers. So these are all the four computers which are connected to this computer. And here I'm saying it is with 2 GB system. This is 4 GB. This is 16 GB system, and it is 1000 GB system. Let us assume. All can be part of my cluster. And when I said that these are the different configured computers which can be part of my cluster, based on this processing power, I'll be distributing the work. In the sense that software, whichever you are using. So, for example, if as I have 100 papers, I'll be given 10 here, 20 here, 30 here, 40 papers here. So, why the distribution is like that? Because the amount of time that is taken by this professor to complete 40 papers is equivalent to the amount of time that is taken by this student who got out of 100 out of 100 in the last semester. The time is going to be same. So, as I know that this is having more processing power, instead of giving 10, 10, 10 and wait, make this everybody to complete 10, 10, you are wasting a lot of resources here because he is capable of doing it. But you are not, if you are not giving, that is not correct. So in the same way, whenever you are talking about this big data technologies or big data, at least conceptually, so processing is exactly that same thing. When you can't do the task in the stipulated time or expected time because of the limited processing power, we can distribute the work to multiple computers. How you can distribute the work to the multiple computers? Because even you see here, so just like that, they haven't come and helped you. Initially, you called them and you made this as a cluster of these people. And this entire cluster is responsible for completing the task of correcting those 100 answer scripts. In the same way, when a particular task is given and if it has to be done in time, I can say it is in less time when compared to a single system. So I'm connecting these computers, and these are all computers only. Now, because when I'm talking about humans, so they are having processing power. When I said it is water bottle, that is about storage. But when I said that this is all about computers connected, so we know that computer is having both storage and as well as processing. So once if you made this as a cluster by using any of the software which supports this big data, I can say that the processing is going to be a bit faster. But the one thing that everybody should understand here is that let us assume that this is same example, whatever that I was telling about this paper correction. If we assume that there is an answer script with roll number 51, if this answer script is corrected by this associate professor, some student got 45 marks. Now, if the same answer script is corrected by somebody else, this professor, then what should be the marks that he has to get? If you say it is a perfect system, obviously it has to be.
Same, it has to be.
Yes, yes, it must be same. So that is very, very important point that you have to remember. Because now with a lot of enthusiasm and this one, those who started learning big data, no, they used to say that. So initially, when I did with one computer, the accuracy is 45%. When he did with 4 computers, accuracy is 49%. When somebody is telling like this is blunder. You need not look into that project. The only advantage that we get here, because in the beginning itself I told, because I want to complete the task in 2 hours. Otherwise, I can do by myself. It may be taking 4 days to complete it. But whatever the marks that a student is getting, either done by me alone or any one of these in the cluster, must be same. And this is applicable even to your big data or anything. How you can say that you are going to get the same output? Because when I said that the data is given to these computers in the cluster, so whatever the program that I have, I'm giving the same program to these 4 computers. Then irrespective of the data, when the same program is executed in multiple computers, obviously it will work uniformly. Don't think that when it is done in the supercomputer, so 2 plus 3 become what? 5. So when it is done in 2 GB system, what is 2 plus 3?
5.
5 only. Even if you do with one supercomputing where you are having at 1 lakh GB and something like i5000 processor, let us assume, because we have i5, i7 like that. Let us assume i5000 is the processor. Even if it is capacity like this, if somebody is saying that they have the program to add two numbers, 2 plus 3 must be 5 only. So nobody in the world should say, hey, because of the technology it has become 5.5.
True.
That's it. Once if you keep these two things in the mind, then really I'm telling you, the whole big data is about how to tackle that storage part and how to work with that processing. So for this, one of the technology is Hadoop. When
Hello,
I'm,
sir.
yeah,
Hello, sir. We are distributing data or tasks. Means there are two things. Now, one is a task related to processing, means
no,
algorithm.
no, only data is distributed. Task is same task. No, paper correction is the task there.
Okay, but in Hadoop, is it possible to suppose task is big instead of data? So can we divide it into subtask and distribute it to processes?
No, 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 I don't think so. But whatever that I know is all about only data distribution.
Okay, sir. Thank you, sir.
Yeah. And storage and processing. So whenever you talk about Hadoop, the component of that Hadoop which is used for storage is HDFS, and processing, any idea? MapReduce. MapReduce programming model. Okay. So I think I'll be stopping in next 3-4 minutes. Yeah, is it okay, madam? Three.
No. Yes, sir.
Yeah, yeah, yes. So if you go to the actual definition, you may be seeing, so it is volume, velocity, variety, and this is the basic definition. And I'm talking about only about volume because I never worked with the other two, velocity and variety. And this volume also, I always worked with only worked with images. That means like huge, like there is a huge number of images. Once again, I'm telling you, huge in the sense it is a relative word. So where it can't be stored in one computer, even if it is possible to store, it is taking a lot of time to process. So for that reason, I always uh, I used only that volume part of that. But even if somebody want to really work with this velocity variety, that also can be explored. And after a few years, initially they started with 4 V's. Then people are crazy about this. No, they added one more V to that big data characteristics. That is veracity. And after that, now this is no first three V's. And after that, they added one more V, that is value. After a few years, that is in 2013, they came up with another three more V's. So they were telling it is seven V's. After that, in 2014, three more V's, and presently they are telling around 42 V's are there, but these are not standardized. But at least that three V's everybody is using, and even some people they are telling 4 V's also perfect definition of big data. Just you explore it. And when I say this is about big data and this is all about the distributed processing, so because of this example, so I don't know how much they really whether you understood it or not. Please, if you want to really look into that, for the time being, you remember these examples. Once if you get clarity by yourself, you can give your try to convert this example by your own example. You can replace this example by your own example. But for the time being, you keep in mind. So I can give guarantee that 90% of the topics which you will be reading on big data will be comfortable to you if you are really follow those two examples. And Hadoop is one of the like a software which is used for big data. Just you these two lines you read. It is open source software. That means 0 rupees. Okay, and it uses commodity hardware. Commodity hardware means the hardware which is available with you as of today. So that means you won't be spending even a 1 rupee on it. So that means total 0 rupees. By spending 0 rupees, you need to do. That is the task of Hadoop. Don't start saying that you will be buying one big server to store Hadoop. Okay, if you want, you can do it. But because of this, the word community hardware, it has become success. That's why I always use it to tell that water bottle example taking from the neighbor. Because there are some water bottles which are available with your neighbor, which they are not using today. That's why you are taking it for time being and you are returning it. Okay. And from where you get this like Hadoop, no? So these are the different versions, 3.3.0 in 2020. And even today I saw it is 3.4 point something is also came in, and that new version has released. And then we worked up to 3.3.1. I think in 2021, 3.3.1 is also came into market. And whenever you want to work with this, no, you need to look for stable versions of it. I think same thing, whatever that is applicable to Python, even for this Hadoop also, it is the same thing. You need to find out stable versions and you have to work. And these are the benefits. So these benefits you can understand directly from that examples I told. Computing power. Because whenever you say Hadoop, the main thing you can say that you are using more than one computer and you are making one cluster. When you made a cluster of computers here, it means you are tackling the issue of storage and you are tackling the issue of processing. So where you can't do with one computer. So obviously I can say that with instead of one computer, 5 computers, the processing power is increased. That is computing power. Then flexibility. The another benefit of Hadoop is that flexibility in the sense, as and when you want to remove some system, you can remove without interrupting the work, so that it provides. And fault tolerance, even if suddenly if there is some system fails, no, it uses the concept of replication factor. By using that concept of replication factor, it handles that fault tolerance. And low cost, so I told no, so software is free and hardware also you need to use community hardware, I can say it is free. And scalability, as and when the task is increasing without stopping the interrupting the work, you can add the number of systems as you want, and you can delete some of the systems according to the data that you are getting. And these are the other components of that Hadoop. And this is how that Hadoop works. So same example. So this is the person, and these are the 4 persons. If you see this diagram, if you correlate that with our paper correction example, actually, where are those 100 papers? Just you tell me that answer, I will be stopping it. So where are those 100 papers? Are they with me or with these 4 people? Hello? Yeah. Actually, yeah, because I distributed that. And the same thing is if you can observe here. Actually, I am not handling any of the papers. I am not doing any paper correction. Actually, here they in our Hadoop also, this is considered as name node, and these are all data nodes. Only the data nodes will have the data. Then what is the role of name node? Name node is used to take care of metadata. And of course, for backup, you will be having a secondary name node. And similarly, this is the model that is used for processing the data, that is MapReduce paradigm. So by using this, so as of now, I told no, so we have done these 4 works from past 3-4 years. So content-based image retrieval by using these big data technologies, and pedestrian detection is done by one of my another PhD student. And latest trend is distributed deep learning. And when I use the word distributed, obviously I'm using Hadoop here, and deep learning also just I started exploring. And content-based imagery is about image processing. So image processing, then big data technologies, and deep learning. By using these 3, you can explore this distributed deep learning. And this is the latest work I told now, where we processed 20 crore images, and not only in the cluster made by us in the computer, and even we are, because during Corona time, as the students are not available, so we have taken the Microsoft Azure account, and in that we made a 18 systems cluster, and there in that cluster of computers, we have processed 20 crore images. Okay, so sorry for taking extra time. If you have any doubts, please you can ask now.
So any questions, please?
So I have one question.
Yeah, please.
So I am a research scholar. It's my first year in Bhagalpur University, Bihar.
Okay.
And I'm just planning to do the my PhD in big data, sir.
Okay.
And so could you suggest me that I mean in which topic I should go for the my research?
See, but you see, I told no. So the only because of the situation which forced me to look into this, I started working in this.
Okay,
So what is the situation to handle more number of videos?
right, sir.
So you also, if at all, if you want to work with any images or videos where you need to process in less time,
Yes, sir.
this is one of the situation. But see, if the best thing is that you can go through different literature and find out the problem, or otherwise you yourself can create, because even today, no, you even if somebody want to work with these videos, still you can do it.
Yes, sir. Actually, sir, I just go through the some Elsevier and IEEE journals,
Mhm.
and I came to the conclusion, sir, go with the data, big data security on the
Okay.
security field over the cloud, sir. Is it good for sir me to go in the? I mean, I'm just asking, sir, am I going to in the right way for the security in the big data? Is it the good or sir go somewhere else? I
Yes,
just,
yes, yes.
I,
Yeah, even I heard, because as the data is distributed among the computers,
yes, sir.
okay, then obviously that as you told, no, that security is one of the component.
Yes, sir.
Okay, then obviously, and even I heard that people are working on that, and surely you can go ahead with that. And here within your your like house-made cluster, it is okay. But as you said, even sometimes the data is stored in the cloud.
Yes, sir. Yes, sir.
Then obviously there is a need of talking about security for it. Then obviously you can go ahead with that. But see, instead of talking about very big terms in the beginning itself, in the first 6 months or 1 year, first start doing some implementation.
Right, sir.
Exactly learn that Hadoop, what is that, then how to make
Yes,
that
sir.
cluster, then what
Yes,
is
sir.
that, what do you mean by processing, what is volume. So from there you started. That is the best starting point. But
Yes, sir.
people know these days directly talking about something which is very big, and but ultimately when it comes to implementation part, no, so we may be struggling to get it. So that's why, okay, you read it. I'm not telling that you should not read, but
Yes, sir.
in parallelly you start implementing some code, then you will get more idea, quick idea. Otherwise, no, every time you'll be talking about theory. So many people say
Yes,
that they studied this, they studied that, this and all. But ultimately, when only when you start implementing, then only
yes,
we'll
sir.
get result, and we'll be knowing how to modify or how to add some more component to it.
All right, sir. So I have one question more, sir. Should
Okay.
I go with the R programming also for the big data security? Is it right?
Yeah,
Or
yeah. Because even I heard that R is of the like a major component,
yes,
though
sir.
with respect to big data. But how that big R is used with big data and all that, I don't know. But major, like almost 50% of the people, those who are
Yes,
working
sir.
with big data, I heard that they work with R.
R
But my
programming.
requirement was different. No, at the time only my requirement was about image processing. That's why
Okay.
we worked with Python plus OpenCV plus this big
Right, sir.
data, that Hadoop and Spark. So these are the
Yeah.
four technologies that we have used
Okay.
when I said that we have processed the 20 crore images.
Okay. So, finally, sir, I would like to ask you, sir, R programming is helpful for me to, big data security on over the cloud. I mean, this program will helpful for me, or some another program will helpful for me, sir. Please
That
guide me, sir.
I'm telling you, I don't have any idea about R with big data, but
Okay.
I know that those who are studying about big data, 50% of the people are studying by using R only.
R only. Okay, sir.
Uh, but I don't know exactly
Okay.
how that R is related to security of big data. I'm not sure about
Okay. Yes. Yes, sir. Thank you, sir. Thank you.
Any other question? Maybe one more question. Okay. So let us thank Professor U.S.N. Raju for giving a wonderful lecture. Especially the examples he has given are very good, and I can see that some of you are commenting, saying that the examples presented are useful, helpful, like that. So we are thanking Professor U.S.N. Raju for making this a successful lecture. Thank you. So now the next lecture is by Professor Pooja Jain. And
Yeah, thank you, sir. Sam.
thank you, Professor Raju.
Thank you, sir.
So she will be talking about data definition, categorization, as well as exploration, preparation. To introduce Professor Pooja Jain, she is currently working with the Indian Institute of Information Technology, Nagpur, in the Department of Computer Science and Engineering. She has nearly 16 years of experience in industry as well as in academics. She worked in many multinational companies like big companies like IBM, CSC, so on. So she is one of the active faculty members at IIIT Nagpur. So now I hand over the session to Professor Pujaji.
Thank you, sir. Thank you so much for the introduction, and thank you for giving me this opportunity to have a session on in ATAL with eminent professors. Thank you so much. So, a very good evening to all the present here. And as sir mentioned, that I would be talking about data. So I was looking, I was hearing Professor Raju's the end part. So he has already covered a lot of things about big data. I would be covering mainly that what is the importance of big data basically, and then I'll be shifting to the categorical data and the types of the data and so on. I would be taking some hands-on as well, and I would actually take a real data set and tell you that how it can be, how the EDA can be performed on that data set. Uh, I would be using Python programming for it. So I won't be dealing with Python commands and etc. in detail, but I would be covering a little bit that how the EDA is performed on a data set using Python. Okay, so start with just a second. I hope the screen is visible.
Yes, ma'am.
Okay. So, data science is comprising of a lot of things: analysis, knowledge, solving, programming, structure, process. It's all this corresponds to data science. So, if you ask me that how do you define data science? Yeah, what is the relationship of data science with AI, ML, etc.? So just to give you a very brief introduction to that. So if I say, if this is AI, this is ML, and this is deep learning. Okay. So this is AI, ML, deep learning. So where does data science resides? Data science is something like this. This is data science, which uses the concepts of AI, ML, and deep learning. It is neither a subset or a superset of AI, ML, or deep learning, but it has something else apart from that. So, like you can say there is something which is known as statistics. So, data science encompasses statistics also. So, it is like this. This is stats. This is stats. So, data science is a combination of stats and some AI, ML, and deep learning algorithms to come up with certain inferences. Inferences because you need to come up with certain inferences so that you can come up with conclusions. Okay, so we'll come up with the actual definition of data science in a short while. But data science, you shouldn't be confused that data science is a superset or a subset of AI, ML, or deep learning, but it is something which is very different, and it uses the concept of statistics along with AI, ML, and deep learning. Then there is something which is known as NLP. So where will NLP reside? NLP is somewhere here. This is NLP. Okay. Then there can be robotics, which is again a combination of NLP, AI, ML, and DL, and so on. So why actually AI, ML, and deep learning is being used for most of the processes is okay, now the data has become like Professor Raju sir was also mentioning that now people don't talk about only data. People talk about big data. Why do we talk about big data is because the data has become very huge. He was giving you some insights on the three V's of data. In fact, I would say there are five V's of data: variety, volume, veracity, value, and uh, and velocity. That is at what speed the data is coming. So you can say velocity, variety. You have a variety of data. That is, some is text, some is images. Then there is volume, a huge volume of data. That is, you have GBs of data that he was talking about. You have videos which are GBs of data, and when you want to process this much huge amount of data, then you need to apply the machine learning algorithms onto it, because machine learning is used only when the data is huge, and huge data means big data. Then there is something which is known as value. That is, whatever data you have, are those attributes actually important to be processed, or there is something which is known as feature extraction, and then you actually identify the features which are to be used for your processing. So which of the features you are going to use. And last one is veracity. Veracity means key, is the data which you are seeing is actually correct or it is fake. So veracity of data is basically used in the case of identification of fake data. Okay, so velocity, variety, volume, value, and veracity. So all these five V's comprise of big data, and we are talking with respect to big data only because the data has become highly high in velocity, high in variety, high in volume, high in value, and high in veracity. So that is why we have started talking about big data and not simply data. So, data science is basically an interdisciplinary field that uses the scientific methods for extraction of knowledge. That is most important part here, knowledge and insights. Now, what is the meaning of insight? Insight is basically inferences. You are trying to give some inferences. Now, you take a very simple example. Um, like you made some dish for your son. Okay, and the son liked it a lot. So what you will do is you will make that dish again the next day. Okay, or you will frequently make that dish because your son is liking that dish, so you're frequently making that dish. So what is the insight that you have taken out is ki my son loves this dish, so let me make this dish frequently. Okay, or I can say ki or I can say that my son comes at 3 o'clock, comes home at 3 o'clock, and then he once he came at 3 o'clock, once he came at 3:05, then once he came at 3:06, 3:10, 3:04. So what is the insight that I have taken out from that? What is the inferences? Ki he generally comes from between 3 to 3:10. Okay, so this is the insight that I have, the inference that I have taken out. So if I have to perform certain actions with him, then or do something, then I would choose the time 3 to 3:10, because this is the time when he comes home. Okay, so I am taking out the insight from the data. What was the data? The data was on Monday he came at 3 o'clock, at Tuesday he came at 3:10, then on Wednesday he came at 3:06, like this. So from that, this is the data, and from this data I have inferred that okay, generally he comes between 3 to 3:10. This is the inference that I have taken out from it. Okay, what is a knowledge? Knowledge is basically meaningful information. Now suppose this is the data for my son. Now I have the similar sort of a data for my neighbor as well. He comes at 2:50, he comes at 2:50, he comes at 2:52, he comes at 3 sometimes, like this. So this is the data for my neighbor, and this is the data for my son. So if I say that I want to find out, I want to prepare lunch for my son, so I should know that at what time is he coming. So is this data useful for me? Is this data useful for me? No, this data is not useful for me because this is my neighbor's data. So this is not required. So knowledge is basically you are trying to retrieve the information which is meaningful to you. I don't need this data at all. I need only this data because I want to prepare lunch. Okay. So I need to have this data for my son. Okay. So secondly, right now, suppose if I have some data related to the images of cats and dogs. Okay. And I want to have a camera on in front of my home, and to identify that which what type of animals do cross by, and accordingly I can give it to the municipal corporation, and they can take care of that. Okay, so I put a camera there, and the camera is actually identifying any matlab the camera remains idle, but as soon as that there is an image of any animal, then it will capture that image, and it will send a notification on my mobile, or it will send a notification to the municipal corporation directly. Okay, so it is continuously checking that whether there is any animal or not. Okay, so there must be many lots of vehicles passing by, there must be many passengers passing by, but I am not concerned about all that data. I am concerned only about the images of animals. Okay, and from that I can infer that okay, generally there is only a dog which comes in front of my home, maybe at 7 o'clock in the evening. So this is the insight that I have taken out, the inference, and accordingly I can tell it to the municipal corporation about it. So a lot of tools are being used. So this is what I was showing you, that how the statistical tools are used. So statistical tools basically comprise of mean, median, mode, or you can go for some normalizations, or you can go for some hypothesis testing, and so on. So this all is done on the data to come up with certain inferences or knowledge. So big data is everywhere nowadays, because since the data is becoming so huge, now we don't earlier, if you talk about some 15 years back, we didn't have any video photography so frequently. Some 20 years back, not 15, some 20 years back, video photography was not so frequent, but as soon as you have mobiles in your hand, people do video photography very frequently, and videos take GBs of data. And in fact, in your mobile also you must be having at least 10 GB of videos and images. And if you want to really imagine the amount of data, then look into Facebook. Facebook is handling a huge amount of data, which you can't even think of the amount of data that it is handling. So Facebook, you are uploading images, and it is a variety of data. You are uploading images, you are uploading videos, you are putting your posts. So text data, textual data, image data, video data, all sorts of data is present there. So now data can be structured or unstructured. In simple sense, videos, images, this is all unstructured data, and Excel sheets, notepad files, text files, this is all structured data. So basically Excel sheets that you prepare is all structured data. And if you talk about in 80s, there was more quantity of structured data and very less unstructured data. As I mentioned, 20 years back, people didn't have much of images and videos, but now people are talking about only images and videos, so that is mostly comprising of unstructured data. So now people have a huge amount of unstructured data. So if you talk about in 2020s, in 2020s it's mostly images and videos, which is unstructured data, and a very small structured data of Excel sheets. So we have this challenge of processing this unstructured data. So what is analytics basically? So analytics is basically data on its own is useless unless you make some sense out of it. So if you have just numbers, it is of no use until and unless you are able to analyze the data well. If you are able to analyze the data, then probably you can come up with certain inferences, some conclusions, some knowledge, etc., etc. So the scientific process of transforming data into insight for making better decisions is analytics. So analytics involves some processes. And what are those processes? The press matlab you can go for business understanding, and then we go for analytics approach. You have data requirements, then accordingly you collect the data. So first of all, you need to decide what is the problem that you're going to tackle. Like suppose if I say I want to find out that what is the percentage of students absent. Yeah, what is the reason for the students absent? Yeah, okay. Generally, what happens is ki the 8 o'clock class in the morning is attended by very few students, and the biggest reason that they give is ki they are not able to wake up properly. So you can, and you cannot make the college from 9 to 5 if it is from 8 to 5, 8 to 4 or something. So 8 o'clock, even if you make it 9 to 5 and you have the 9 o'clock lecture, then also the students are not going to attend. They will have the same reason that we are not able to wake up. Well, even if you make it 10, then also it will be the same reason. So it is not basically about the time, it is about the first lecture. Okay. So what are the things that you can do to make that first lecture interesting so that the students start attending it? Okay. So what is my problem? My problem is to analyze the past data and then come up with an inference, and find out ki how I can improve the attendance of the students in the first lecture. This is my problem. Okay. So for this, I have to analyze the data for each and every lecture. Okay. So I am going for an analytics approach. Data requirements. What is the data that I need? I need to find out the attendance in each and every subject along with the timings of that lecture. How will I collect that data? I have to maintain an Excel sheet for it, ki how many students are attending it, and take an attendance for it. Then I have to actually understand the data, that is data exploration, EDA, and preparation of the data, because the data can be in different format. Like suppose there can be a mobile app to record the data. Now this the data that is coming through the mobile app is not in the Excel sheet format. It's not in Excel format. It's in a different, like suppose it is in a text format or it is an HTML format, so I have to convert it into text format, Excel sheet format. So that is data preparation. You need to prepare the data. Now sometimes it happens that the faculties forgot to take the attendance, so it is a missing value, so I have to perform certain operations for the missing values, etc. So this all corresponds to handling with the data. This all corresponds to handling with the data. So once that data is, so this is the part. So this is the part that actually deals with how to handle the data. Once that data is handled, then I'll go for the modeling part. Modeling is done with the help of machine learning models, and then we do the evaluation, deployment, feedback. This is all related to ML, the ML part or the deep learning part. And this is basically related to the data science part. That is how you are actually handling the data. Well, machine learning is also a part of DS only. That is, DS comprises of implementation of ML models as well. But this is the core talking about data. So exploratory, visualization, confirmatory. So we'll take a data set and see that how we actually do the visualization of the data and then come up with certain inferences. So there are 4 types of analytics that can be done: descriptive, diagnostic, predictive, and prescriptive. So descriptive is present tense, what is actually happening. Diagnostic is why did it happen. Predictive is what is going to happen in the future. And prescriptive is ki if suppose I am predicting a good thing. So prescriptive is basically that is how to continue that good thing. Or if I'm predicting something wrong, then the prescriptive is how to stop that. Okay. Now suppose, now taking the corona example, now that is the one which is frequently used as an example nowadays. So descriptive is ki I'll say that okay, today there were 10,000 cases, yeah, 200 cases or 100 cases whatsoever. So descriptive analysis is what is my current okay, let me have it like this. Ki there is a company, there is a company which is not doing very well. Okay. So I would say that okay, the turnaround of this company in this particular month of December is 10,000 crores. So this is my descriptive. Diagnostic is key. Generally, it had to be 20,000 crores, but this time it is 10,000 crores. So, why did it happen? That is diagnostic. Predictive it is key. Diagnostic is on the basis of the past tense. Okay. So, why did it happen? Earlier it was 20,000 and now it is 10,000. So, what is the problem? That is diagnostic. Predictive is key. I am predicting that in January my turnaround would be a little better and it would be 15,000 on the basis of various factors. It can be anything. Like suppose if I am selling woolen clothes, so definitely if I'm selling woolen clothes, was it visible? Okay. Just let me know as soon as you are unable to see the slides or hear me. Okay, so I hope it is visible.
Yes, ma'am.
Okay. So predictive analysis is basically I'm since I'm selling woolen clothes also along with summer clothes. So I'm predicting that in the January my sales would be quite good and my turnaround can be 15,000 crores. So this I'm predicting. Prescriptive is ki, what should I do so that my turnaround becomes 20,000? Okay, so earlier in November it was 20,000, in December it is 10,000. I'm predicting it to be 15,000, but can I make it 20,000? That is prescriptive analysis. So there are certain parameters which are required to be studied, to be analyzed, so that we can come up with such types of analysis. Okay, so the future is prescriptive and predictive, and past is diagnostic and descriptive. So what has happened, what should we do, and what could have happened, like this. There are lots of applications of data science in each and every field because, as I mentioned, the data is becoming huge in each and every sector: healthcare, internet, targeted advertising, image recognition, speech recognition, blah blah blah. In each and every field, the data has become very huge, and you need to apply the data science on that data to come up with certain inferences or conclusions. So education and research, the COVID-19, I'm talking about the data science of COVID-19 in different fields. Like in healthcare, of course, it was being used. That is how to avoid a number of cases to be go down. Governance and management, that is what is the government actually doing to maintain the number of patients, or then or they are increasing the beds in the different hospitals. Recently, some 2 or 3 months back, there was a danger of COVID again coming. So so the government had already taken a lot of precautions in which they had increased the number of beds in many of the hospitals, and they had also increased the speed of giving the vaccinations. So this was by the governance. So again, they did the prescriptive analysis, the descriptive analysis, and all types of analysis to identify that okay, maybe in the near future the number of COVID is patients are going to increase, so we need to increase the number of beds in the hospitals. Education and research, can we have some vaccination which is which needs to be taken only once and not twice, etc., etc. So let me skip this and then come to data. So a data is nothing but an entity. Then it will have an attribute. So data is a measurement of an attribute. So like if you say name is ABCD, age is 34, this is all data. F gender is female, salary is 40,000, employer is XYZ. So this is all data. Okay. So the data in data analytics is actually, there are many types of data that can be used to measure the properties of an entity. So there is something which is known as scales. There is something which is known as scales, also called as scales of measurement. So the scales of measurement is, that is how you are actually measuring a data, measuring an attribute or measuring a data. This is a qualitative, matlab the data can be divided into two types: qualitative data and the quantitative data. So it's very clear from the words qualitative and quantitative. Is quantitative is talking about quantity, and quality is talking about categorical data, basically, which is not quantitative. Okay, and quantitative can be discrete or continuous, and continuous can be interval or ratio. So we'll talk about that in a better way by using the Neuer terminology, or you can say the Neuer nomenclature. So the Neuer nomenclature is basically the classification of the sales of measurement, and it's nothing but N stands for nominal data, O stands for ordinal data, I stands for interval data, and R stands for ratio data. So this is just to remember it: Neuer, nominal, ordinal, interval, and ratio. So data types can be extended. Data types are built on this same nomenclature of Neuer: nominal, ordinal, interval, and ratio. So what exactly all these are, we'll talk about that in detail. So the Neuer classification says that there is nominal, ordinal, interval, and ratio. The nominal attributes can be divided into three types: binary, ternary, and others. Ordinal can be of three types: alphabetically, numerically, and literally. Intervals can be discrete or continuous, and binary can be symmetric or asymmetric. So all this in green is numeric, that is the quantitative data, and all the blue is in qualitative data. So this figure which I showed you is basically talking about the qualitative and the quantitative data. The nominal, ordinary, and binary. This is all, the blue part is all categorical data. It isn't categories, it doesn't have numbers. It doesn't have 2, 3, 400, 200 like this. It doesn't have numbers. It is simply categorical data. Like, for example, if we talk about gender, so male, female, or you talk about the color of the car. So red, green, blue, orange, yellow. This is all categorical data. Numerical data is age. If I say 10, 20, 26, 30, 40, 50, this is all numerical data. Marks in a particular subject, this is also numerical data. So there are certain properties of data. Some of the nominal data or the categorical data will have those properties. The categorical data have the properties of whether they are equal or not. So if I say red color, I have a red color car and my neighbor also has a red color car. So this is equal. Both have red color car. I have a red color car and my boss has a green color car. So this is not equal. Okay. So categorical data can have equal to and not equal to. And then there can be ordered also. Like suppose I said, ki I got a grade of A plus. My friend got a grade of A. So this is an ordered data. So categorical data can be ordered also, because A plus is of course greater than A, and A is greater than B plus, and so on. So there can be an order. A plus is greater than A, that is greater than B plus, and so on. Then addition and subtraction and multiplication and division can only be done on the numerical data. So I have an age of 26 and my friend has an age of 27. So these two ages can be combined together. Total age, I can give the total age, or I got my student got 20 marks in one subject, 30 marks in another subject. So total marks is 50. So all this can be done on the numerical data only. The four types of operations of addition, subtraction, multiplication, and division can be done on numerical data only. So nominal data will have only distinctiveness property, that is equal to or not is equal to, like this. Ordinal will have distinctive and order property both, and these two are categorical data. Okay, categorical data. And these two are nominal data. Numerical data. Numerical data. So interval data will have additive property plus property of ordinal data, that is less than, greater than, and ratio will have the multiplicative property plus property of interval data. That is, it will have addition also and ordinal also. Okay. So so nominal and ordinal are collectively called as sorry, actually I'm having cough from past 4 days. Just give me a second. Okay, the categorical data or qualitative data, which I showed you in this diagram, this one. Nominal and ordinal together are known as qualitative data. Okay. So the nominal scale says I can have gender as male and female. So it will have mutually exclusive codes. Mutually exclusive codes means it has nothing to do, one thing has nothing to do with the other thing. Mutually exclusive. This is an important mutually exclusive code. Mutually exclusive code means keep the country code for India is IND, suppose. The country code for Pakistan is PAK. For Bangladesh, it is BAN. The country code of India has nothing to do with the country code of Bangladesh, or it has nothing to do with the country code of USA. Blood groups, or matlab, I have a blood group of B positive. My neighbor can have any blood group. There is nothing mutually exclusive. I am female. If I come across any other unknown person, so it's not necessary that it has to be a female only or it has to be a male only. It can be anything. So this is mutually exclusive. So it can be either using numbers, but even if you are using numbers, this is this when I'm talking about. Even if you are using numbers like this, it doesn't mean that you can do some operations on those numbers. Like suppose if I say I have the roll numbers. Roll number starts from 1, 2, 3, 4, 5 like this. But if you say I add two roll numbers together, 20 and 30, so then it doesn't make any sense. Okay. Now the prisoners are numbered as 100, 101, 102 and so on till 110. But if I add two numbers together, then it is not making any sense out of it. Okay. So even if they are numerical, but then too, they will not make any sense. That is, you cannot do addition or subtraction or multiplication, division onto that data. Okay. So, so the nominal scale is to use to label the data categorization using a consistent naming convention. A consistent naming convention is, okay, I'm saying that okay, female stands for F and male stands for M, like this. So this is a standard naming convention. Can be numbers, letters, strings, or if I can say that okay, female stands for 1, male stands for 2, like this. So this is a naming convention that I've applied. It can be anything. So nominal data thus makes a category. So nominal data thus makes a category of a set of data. That is, I have a category. This is all categorical data. So I have a category of data. And they will not have any ordering because these are mutually exclusive. One data has nothing to do with any other data. Okay. Then binary scale is basically, as the word says binary, it will have only two values: 0, 1, on, off, switch, on, off, true, false, yes, no, etc. So it will have only two possible values, but then too they are mutually exclusive. There is no logical order about it. Okay. So binary data and nominal data. Now, the binary data can be symmetric or asymmetric. Symmetric means key equal importance. That is, matlab, if I am passing across an unknown person, then there is equal possibility of him being a male or a female. There is an equal probability. Okay, na? Or that is equal probability. That is 50-50. He can be a male also, it can be a female also. And if there is an unequal importance, then that is known as asymmetric binary variables. Like food preference can be said as veg or non-veg. ठीक है ना. So if we consider a simple or you can say Jain family. Jains are generally pure vegetarians. So if you are talking about Jain, if you are asking any Jain person, then it is 90% cases is it has to be a pure vegetarian person. So that is asymmetric, because 90% of the cases you will have a pure vegetarian Jain. There will be very few people who Jain, very few Jain who eat non-veg also, about 10% or even less than that. So this is asymmetric data, asymmetric binary scale. So binary, why binary? Because there are only two options, veg or non-veg. Okay, so it is binary. But asymmetric and symmetric is कि male or female, this is symmetric. There is a 50-50% chances. And in the case of veg and non-veg, if I'm talking to a Jain person, then of course it has to be 90-10 rule. So asymmetric and symmetric. Got the idea? Then what are the operations that can be performed on nominal variables? So as we mentioned, on nominal data, the categorical data, we cannot apply addition, subtraction, multiplication, division, etc. But we can go for mode and correlation. So we'll see that in the later part of the session, which I'll take a data and then apply the EDA, etc. And we can combine the nominal variables together, like gender is combined with marital status, like this. So that can be done. Ordinal scale. Now what is the ordinal data? Ordinal data is which has a fixed order. So we have S, then M, then L, then XL, then double XL. If you go to a mall to buy a shirt, so you ask him to show the medium size. If the medium size doesn't fit you, then you'll go for L. If L also doesn't fit you, then you'll go for XL. So this is a fixed order. There is an order on that. And you will have relational operators on this, greater than, less than. So S is smaller than M, smaller than L, smaller than XL, and so on. Or I showed you an example of grading system. So A plus is greater than A, is greater than B plus, and so on. This is known as ordinal scale. So again, you cannot perform operations on the ordinal data because that is also categorical data, but you can perform the mode and the median onto this. Interval scale is basically if you have a huge data and there are fixed intervals in between, like weight, height, latitude, longitude. Latitude and longitude is the best example of interval data, because there is an interval of 1 degree between every latitude and 1 degree in every longitude. So interval data is a quantitative measurement scale where there is an order, and the difference between the two variables is meaningful and equal, and the presence of zero is arbitrary. What is the meaning of presence of zero is arbitrary? Because this is the only sentence which makes interval scale different from ratio scale. In the scale of in ratio scale, actually zero has an importance, but in interval scale zero doesn't have any importance. It is arbitrary. Like if I say interval data has a 0 point on origin, but origin does not imply a true absence of the measured characteristic. So for example, temperature in Celsius and Fahrenheit, 0 degree does not mean absence of temperature. Well, a 0 degree Celsius or 0 degree Fahrenheit doesn't mean an absence of temperature. Okay, so interval scale, again, temperature will also have an interval scale. It is a numerical data and it is at intervals, fixed intervals. Age is also an interval scale because it can zero is arbitrary in that case. Okay, calendar dates, temperature, this is all interval scale. We can perform addition, subtraction, multiplication, division, and so on the interval data, as well as on the ratio data. So the only difference between interval and ratio is the ratio will have a definition of zero. So any ratio data is an interval data, but not the vice versa. So all ratio data are interval data, but not the reverse. All ratio data are interval data. Okay, because the only difference lies is with the zero part. The zero will have some meaning in the case of ratio scale, but not in the interval scale. Vishwanath sir, should I give a break? Because as it was mentioned, 8:50, we need to give a break. So do I need to give a break or I can continue?
I think that there is no need to have any break because only half an hour is left now.
Okay, take care.
You
So then
can,
I'll continue with this.
yes, madam.
Okay. So again, on the operations on the ratio data, you can perform any types of operations, addition, subtraction, and so on. So at this point of time, I will just ask any questions if you have, and then I would take an example of data set and perform the EDA and visualizations and all those things on that data. So let me know if you have any doubts or questions on this. Any doubts, questions? I hope you were able to understand that what is data and what are the different, the Neuer terminology used for it.
Yes, ma'am.
Okay, thank you.
Yeah, you're welcome.
Ratio scaled variables. Yeah. So the ratio scale variables, as I mentioned, all the interval scale data can be termed as ratio scale data. The only difference lie would be ki ratio scale will have the value for zero as well. So the intensity of the earthquake, sound intensity in decibel, or you say, the best example is cost of an article. So sometimes you get an article free of cost. Free of cost means the cost is zero. So zero is also there, and there can be a cost of 100, 200, 300, 400, etc., etc. So that is a ratio scale data. Okay, Anantha ma'am. Okay, sir,
Yeah.
Anantha sir. Okay, so let's move on to the example that I was saying. The best way to acquire the data, because as when we saw, this the process which was involved in solving, yeah. So this was the data science process that is used, and in that we said data requirements, data collection, data understanding, and data preparation. Now, data understanding and data preparation will involve Python coding, but data requirements and data collection will actually not require Python coding, but it will require that how you are capturing the data. Like one of my student, my PhD student is working on speaker verification. So speaker verification of children. So she had to record the speech of lot of children. So she actually went to the different schools and recorded the speech of children of ages from 5 to 13. So that was data collection that she did, and it took her somewhere around 6 to 7 months to get that data, because COVID also pitched in and she was not able to get that. So first of all, she decided that she wants to work on speaker verification. That was the problem definition. Then she realized that okay, she would need a lot of data for the analysis of the speaker, analysis of the voice and speaker voice. So she said that okay, I need to collect the data for it. And once the data was collected, then she applied a lot of EDA and the preparation of the data, because some of the files were WMV files, some of the files were MOV files. So she had to come up with speech, the data, and then the data should be uniform throughout. So like some of the children were speaking for 10 seconds, some of the students were speaking for 5 seconds. So she had to do the pre-processing of the data and commit to a uniformity of 5 seconds for each and every child. So this all corresponds to data preparation. Kaggle is a website which contains a lot of data. Kaggle. Kaggle. So if you have decided that I am going to solve so and so problem, then you can search for that particular data set on Kaggle. So let's see what are the different data sets which are available. Paper citations, automobiles. Okay, let's go for automobiles. Okay, let me download the data set. So if you see the data set, this is the data set. So this is symboling, normalize, make, fuel type, aspiration, number of doors, body style. So there are so many columns, so many attributes, so many parameters. And on the basis of analysis of all these parameters, you are deciding the price of the automobile. What is the stroke? What is the horsepower? What is the peak RPM? What is the fuel system? What is the bore, etc., etc. And on the basis of that, you have the price of the car. Okay, maybe it is in hundred thousands or something like that, or thousands, whatever. So this is the price on the basis of sedan or hatchback, or this is the drive wheels, four wheel drive, or it is RWD, or it is an engine, whether it is in the front or it is at the back, it is gas or not, etc., etc. So there are lots of attributes, and on those basis you are predicting the price of the car. Now, I just want to analyze the data. I'm not doing any predictions. I'm not doing any predictions, so that means I don't have to apply any machine learning algorithm onto it. I'm just applying the data science part. That is, I'm trying to analyze the data. Okay, so the analysis of the data, which comprises of doing the data preparation and also EDA, that is the exploratory data analysis. That is how the data looks like. Okay, how the data looks like, data exploratory analysis. So let's see if I have some code also here. So yes, there is a code, EDA, automobile dataset. You can use the Kaggle code which is present, but you need to modify the code as per your requirements, because of course you cannot use the data as it is and then you can publish a paper on it, which is not, you cannot do it actually. So you have to modify the code which is available on Kaggle as per your own requirements, and then you can come up with certain new innovations or new things which we can put it onto the paper. So I just clicked on run all, which will execute all these boxes. Yeah, code blocks, all the code blocks. So I'm not getting the getting into the deep of Python part. Sorry. Sorry, just give me a second.
Ma'am, you can take a break for a few minutes. It's required.
No, it's fine. I'll continue. Actually, I was suffering from fever from past 5 days and with cough also. Thank you, ma'am. Okay. So I'm not getting in the details of the Python code. This is the data set which I showed you in this So this is the data set, head and the tail. The head is the first 5 rows and the tail is the last 5 rows. And if you check the columns, these are the different columns. And if you see here, there are lots of columns which are categorical. So I need to first convert this categorical data into numerical data to be so that I can apply a machine learning algorithm onto it and do the analysis. If I'm checking the summary, so symboling is a integer data, but make, fuel type, aspiration, number of tours, this is all categorical data. Object means categorical data. So it says ki where the data type is equal to object. So this is all the categorical data which needs to be converted to numerical data. And now I'm going for univariate analysis. Univariate analysis means I'm trying to analyze only one parameter at a time. Only one parameter at a time. So when you are doing the analysis of only one parameter at a time, like suppose you do it with make. So you say how many cars are from Toyota, how many cars are from Mitsubishi, how many cars are from Volvo, and so on. This is univariate analysis on the basis of make. Fuel type. So there were 175 cars of gas and there were only 24 vehicles of diesel. Aspirations 160 of STD and approx 30 of turbo. Number of doors mostly were from 4, but there were some cars with 2 doors also. Then I can go for sedan, hatchback, wagon. So sedan were somewhere around 85, hatchback were 62, wagon were 23, and so on. So this is bar graph, and I am taking 2 colors here, number of doors. Here I am taking different colors for different so value counts. That is how many counts do you have of values? What are the values? Sedan, hatchback. So what is the count for it? How many sedan cars, how many hatchback cars, and so on. And then I can go for category plots. So drive wheels, there were 3 types of drive wheels, FWD, RWD, and 4WD. Engine location was on the front or the back, and so on. This is the numerical columns. Now in this numerical columns, if you see, curb weight is 2548, 3062, and so wheelbase is 88.6 or 109. Symboling is only 3, 1, 2, -1, and so on. So if you see, there is a huge difference. And if you talk about price, that is a different value altogether. A very, very high value. So if you are trying to analyze price with symboling or price with bore or with stroke, you will not get good answers because there is not a good relation between two. Stroke is in the range of 3 and price is in the range of thousands, 10,000s. So you won't be able to get a proper justification of this. So you have to do the scaling. There are different types of scalings which are used: min max scaler, normalize standard scaler. So I can go for we'll see about scaling. And now what I'm trying to do is I'm making a distance plot, and in which I'm making a figure also. So if you see, there is a graph which tells that how the symbolic is changing. Your normalized loss, engine size, horsepower, peak RPM. This is all univariate analysis. Price. So mostly the cars are in the range of 8,000 to 20,000. Mostly are in this range. Very few are in the range of 50,000. Okay. So price is done. Next, come to bivariate analysis. Before we continue with the bivariate analysis, we have to first check. No, why do we do actually bivariate analysis is, do we have any correlation between the values? Like if one is increasing, the other is increasing. If one is decreasing, the other is decreasing. So do we have any correlation between the variables? That is done with the help of bivariate analysis. So there are two parameters which are compared together. So if you see here an example of price with symboling, if you see for zero symboling, the price is in the range of 5,000 also, and is in the range of 20,000 also, and is in the range of 40,000 also. So there is no relationship between price and symboling. It's not correlation. There is no fixed correlation between symboling and price. Ki as the symboling is increasing, the price is also increasing. Nothing like that. So since there is no correlation, then I'll have to consider. This is basically finding out the importance of the different features. When you do try to apply the machine learning algorithm on the feature set, then you need to identify. Now there are so many features. You have so many columns here till y. So you have approximately 25 columns. So since you have 25 columns, so you cannot have all these 25 parameters fed into the machine learning model. You have to reduce the number of the parameters to get better results. To reduce the number of the parameters, you have to identify the importance of each and every feature. Is this feature playing a major role in identification of the price, or is this feature useful in identification of the price? So symboling, we actually know that it is not adding any value to the price, so we can avoid this symboling parameter when we are giving these parameters to the machine learning model. Similarly, I can make the box plot. So from next time when I'm trying to prepare a machine learning model, I will not give symboling as one of the parameters. I can go for box plots also. So the box plot says ki if it is a Mercedes Benz, the lower price is 25,000, the higher price is 45,000, like this is a box plot. Box plot for aspirations, turbo, number of doors, etc., etc. This is all box plot for two different features together. Heat map is basically a correlation matrix which gives the correlation between all the attributes at one go. So if you see here, the normalized loss with price, wheelbase with price. So wheelbase and price has a correlation factor of 0.58. So 0.58 means ki it has a 50% correlation. 0.1 means it has only 10% correlation, and so on. So if the value is very high, then that means, okay, if one is increasing, the other is also increasing, like this, correlations. So what are the inferences? Engine size, curb, weight shows strong correlation with the price of a car. Horsepower also shows strong correlation with the price, and it is in a positive correlation. So if you see horsepower, let's see horsepower. Horsepower has a correlation of 81% with the price. So as the horsepower is increasing, the price of the car is also increasing. So in this case, horsepower has become a very important parameter to be fed to the machine learning model to identify the price of the car. Okay. And it's a positive correlation. It is 81% in positive. For engine size, where is the engine size? Here, 87%. That is also very important. Curb weight, curve weight has 83%. So again, this is very important. So I am trying to figure out those features which are actually playing a major role in the identification of the price, the correlation. Next, we come to data pre-processing. So pre-processing involves a lot of things: missing values, removal of the missing values, or removal of the null values. And also you can say that some of the values, well, the missing values can be replaced. Like for example, let me show you this. So there can be nothing here. So in this case, I can either replace it with the top one, or I can replace it with the average. Like suppose if I say wheelbase, this is a numerical data and this is missing. So what I can do is I can find out the average of the complete column and then replace it over here. or I can replace it with the previous value. I can do any such sort of a thing. Okay, so data pre-processing involves removal of the missing values, removal of the null values, then standardize scaling, and one hot encoding is basically conversion of categorical data to numerical data. So this all is done in the case of data pre-processing. And what all we have done till here, that is creation of the box plots, creation of the maps, univariate analysis, this is all within EDA, exploratory data analysis, in which I'm trying to explore the data, that how the data looks like. Yeah, what is the relation between the two different parameters together, or one parameter taken only once, univariate and bivariate, this all corresponds to EDA. Fortunately, in this case, I don't have any missing values. If you say is NA and sum, so I'm trying to find out the sum of rows which has null values. So this said it was 0. So there is not a single null value. So I'm happy in this case because I don't have any null values. If I would have, let me show you one another code which I wrote. So this is all EDA, exploratory data analysis, and this I'm trying to find out the correlation matrix. This is the heat map, pair plot. This is a pair plot, box plot. This is all visualization things. No, here this doesn't have. Here it is. So I am filling the glucose value. The glucose had lot of null values. So I am filling it with the mean. I'm filling the null values with the mean of that particular column. Blood pressure is also filled with mean. Skin thickness is filled with median. Insulin is filled with median, and BMI is filled with median. Okay, so either we can replace it with mean, median, or mode whatsoever. So I am replacing glucose with mean, like this. So this takes care of missing values removal. Yeah, replacing the missing values with the mean, median, or the mode. Okay. Now this is again the box plot. This all comes inside the EDA. Now this I was trying to show you the scaling part. These are very the scale of the values is very different. Symboling has the values between only 3 to -1, but price has a very huge value. So we have to go for scaling. So either I can go for standard scaler. So if you see standard scaler, the difference between standard scaler and min-max scaler is, in the case of the standard scaler, the mean is reduced to 0 and standard deviation is reduced to 1. So if the mean has to be reduced to 0, so it will have the negative as well as the positive values, because the mean has to be reduced to 0 and standard deviation has to be 1. So it will have negative as well as positive values. And but if you see the graph of it, it would be same for min max scalar also and for a standard scalar also. If you see, all the values have been normalized, price is also normalized. Okay, yeah, scaled down. And the min max scalar actually gives the values between 0 and 1. See, this is all 0 and 1. Price is also 0 and 1. So now you can do a proper analysis, because the scale of the different attributes is same. But if you plot the graph of both the ways, which was firstly done with the help of standard scaler and then with the min max scaler. So if you see, the graph is the same. So it doesn't make any difference with whichever scaling technique you can use, you can use. Robust scaler is another type of a scaling technique. Again, the plot will remain the same. And there is something which is known as normalization. So you normalize the values like this. So this is all talking about the pre-processing, and this comes the encoding part. Encoding means conversion of your categorical data to numerical data. So first of all, you try to find out the value counts. Value counts means how many cars have FWD, how many RWD, and how many 4WD. Similarly, I did it with fuel system also. And then I am replacing this values with numbers. Now, since it had an error, so it won't be able to exit. Yeah, if you see here, 2 and 3 was converted to engine type. Replace, there is some error here. So I can replace this with fixed values. I think I have done it over here. Let me show you. Yeah, scaling. And this doesn't have that. So scaling, and then you need to convert the categorical data to numerical data. So what is conversion of categorical to numerical data is like, suppose I want to replace 2 with 2. This is replaced with 4. This again 2. This is conversion of categorical data to numerical data. Similarly, I can say STD stands for 0 and turbo stands for 1, like this. Or I can go for Audi. Alfa Romero is 1, Audi is 2, like this. The BMW is 3, Chevrolet is 4, and so on. So I am doing a one hot encoding in which I am converting your categorical data to numerical data, like this. See, self-employed has lot of null values, so I can completely remove this column. If that column is not used for my machine learning operations, or it is not playing a major role in identification of my target value, I can remove the column completely. Or I can give some default values. So see, if you see here, I am filling it with the default integer, default string, default float, like this. So maybe the strings are replaced with NaN. If it is a self-employed, has to be a string, so it will be replaced with spaces, like this. I need to convert all to lowercase also, so that it is, I don't, when I'm replacing the male with 0 or female with 1, then it doesn't give any problems. And sometimes it happens that male is mentioned as male, malish, maley, male, mal, because there are different, because the data was entered by different people throughout throughout the world. So maybe they are writing it in a different spelling or something like that. So that also needs to be taken care of. So this is all forming a part of pre-processing. Now, this was filled with median. Age had lot of null value, so that has been replaced with median. Self-employed. Now, this is encoding data. This I was trying to show you. That is how you encode the data. So you this encode data is a part of the Python programming code. This is a Python programming code which will actually find out the value counts, that is what are the different values for each and every parameter, and then accordingly it will give you 0, 1, 2, 3, and so on. It will give a unique value to each and every value. So it will transform. So label age is given this, the labels which are given to the age, to the gender, to the country, and so on. So to every, like, see, if you see here, age is given these values, gender is given as 0 and 1, self-employed is given as 0, family history, all has been converted to numbers at one go. So this was the complete code to actually convert your categorical data to numerical data, and you will have such types of values. And then you check that what are the missing values. So if there are no missing values, then again, then you can go ahead and do your heat map generations. This is all EDA, exploratory data analysis. So you are trying to visualize the data and do the bivariate and the univariate analysis to find out whether what is the correlation between the different parameters. Okay, gender, blood group, and so on. So coming back to this part, and then I can check for the final shape. And then once all this is done, then of course I can go ahead and apply the machine learning model onto it. So from this, actually, see, if you see probability of the mental health condition, so females are standing with blue and male is with orange. So the probability of um, work interfere means ki, how many times work is affecting the mental health. Work is affecting the mental health. So very few people say never. Some often, many a time say often. Often is blue is females. So point 0.9 ladies or females are saying that yes, often it is the time that work is interfering with the mental health. Rarely, sometimes. So most of the people are saying it often. Males also, transgenders also, females. Rarely females are saying it, and then rarely males are less, which are saying that okay, no, it is not taking care, the work is not involved in mental health condition. So looking at this particular figure, you can analyze that what is the common belief between the different sets of people. Okay, then scaling and fitting, this is scaling, the same scaling which I mentioned, that is age is now scaled because age was having a different value and the rest of them was on 0 1 2. So now age has been scaled using the min max scaler, and then I am splitting the data for application of the machine learning algorithm. Okay, so I think we can stop here, and let me know if you have any doubts or questions at this point of time.
Yes, ma'am. So if the participants have any doubts, please raise your doubts.
I hope I was able to tell about the data part and how that code is being used for the analysis of the data, exploratory data analysis, and the preparation of the data, cleaning of the data, and so on.
Yes, ma'am. So actually it is a practical session.
Yes, sir.
I have one small question actually.
Sure, sir.
Categorical data to convert into numerical, do we have only this one hot encoding or something like that, or
So
is
there
there
is
a,
one more way in which actually the number of columns are increased to a great length.
Mhm.
In which we give it as 0001. So wherever the value is for that particular attribute, we put it 1, and for the rest of them we put it as 0. But the only problem is the number of columns increase. Like suppose if there are 20 values, like suppose countries, we are talking about countries. So there are 20 countries in the data set. So in that case, what will happen is 20 columns would be added. And so wherever there is India, it would be 1, and the rest of the columns would be 0.
Yes,
So that is also used sometimes, but the only thing is it occupies a lot of space.
yes.
and giving these value, but the processing speed is increased in the sense because we are talking about binary numbers, only zeros and ones. So the processing speed is slightly increased, but the data that is required, the space is required is lot. So we go for one hot encoding, which gives you as values as 0, 1, 2, 3 till 19 for countries.
Yes. Thank you very much.
Thank you, sir.
So any other questions? If there are no more questions, let me thank the speaker, Professor Pooja Jain, for a practical and wonderful lecture. So thank you all. See, I wish to meet all of you tomorrow, and please inform to your friends who are in this workshop to join, because this is the workshop where the participants have opted for this workshop. They have registered for the workshop. That's why AICTE has approved for the workshop. Okay. So please ask your friends who are in this FDP to join tomorrow's session. Thank you very much. Thank you all.
Thank you, sir. Thank you so much. Thank you.
Thank you, ma'am.
Patient listening.
Thank you.